I'm Rick.
Hi, I'm Oscar. Rick, you prepared something.
Yeah, I would like to dive into gRPC.
I was waiting for that one.
Okay, so let's dive right into the presentation. So gRPC.
We got this shipped with the 3.0 of .NET Core, the ASP.NET Core stack.
Yes, and the cool thing is it can also be a self-hosted application.
Mm-hmm.
So it doesn't need to be under ASP.NET,
Mm-hmm.
but as people could have seen in your previous talk on ASP.NET Core 3,
Mm-hmm.
you can also add gRPC there as an endpoint, and
As
then
an
it will
endpoint, yeah.
just work. So gRPC is actually a modern open source high performance RPC framework.
Mm-hmm.
And we know RPC from way back when. We had remoting
Yeah.
on .NET, was a long time ago.
Yeah. RPC stands for Remote Procedure Call, right?
Yeah, so what you're actually doing, the name says it, you're calling a procedure on a remote instance of a class or whatever. So it can run in any environment, and in the end it can efficiently connect services in and across different data centers.
Mm-hmm.
So you have pluggable support for load balancing and tracing and health checking and all that kind of stuff. But in the end, it's like you're calling a procedure on a class, so like a method on a class, except the class is not hosted in your client, it's hosted on a server somewhere. So it has a simple service definition, you can start quickly, and you can scale really easily. And you can, as I said earlier, work across languages and platforms, so it also has bidirectional streaming and integrated auth. And the cool thing about the streaming, of course, is that you can have your client server really have like a...
Yeah, you can go both ways. It's pushing,
Yeah.
pulling. Like it's different than the
I wanted
model.
to say chatty, but
Chatty,
then
yeah.
it looks
Yeah,
like chatty I/O. That's something you don't want.
No, but you can do small messages, and you can do it asynchronous, and it's different from the I do a call, I wait for a response, and do something with it.
Yes.
So there are more things. It's apparently a socket.
Yep. Yes, it is a socket, and then by default it talks protocol buffers. And if you look at these protocol buffers, you actually see it's sort of like a class definition, right? So for instance, here we have a name and an email and some very long property name. But the strange thing is, numbers are, it looks like, assigned to, for instance, name, email, and some very long property name. But that's actually the index of the value of the property in the buffer. So here you specify name is first, then comes email, then comes some very long property name.
Okay.
And where, for instance...
so it's really pushed together. It doesn't have the description. It's really compact.
Yes, so if you look here, on the left, we can see person.xml, which has the properties that I just had earlier. But as you can see, the downside of XML, of course, is the fact that opening and closing tags have the entire name of the property.
Yeah, so you're like double having the property name always in there twice at least.
Yeah,
so that's a bit of overhead.
That's size, right? So here you see some very long property name, and then it's there twice, only for the value hello there. So this entire file is 157 bytes if you open it. Still not a lot.
I've seen bigger XML.
Yeah. But just for this simple example, we can see this is 157 bytes. Now, if we look into JSON, of course, JSON is a lot more concise because you only specify the property name once, and then you specify its value, and then the next property comes. So if you look at this file in JSON, it's 142 bytes.
Okay.
I do have to say, for instance, with the new system.text.json namespace, and with all the serialization in there, by default they do optimize JSON, so they don't have indentation, they don't have.
Okay,
so they do
but that's
minified JSON.
Only the white space and the line breaks.
It might
pulled out.
It might strip off a few bytes, but still, it's smaller than XML, but it's still some file, right?
No.
Then if you look into the protobuf file, you see the value of the first property, the value of the second, and then the value of the third, with some binary stuff in there, which actually defines, okay, because I said name is the first property, between the first two indicators, that's the first name, or the name.
But with a protocol like that, there is a difference, because it's not self-explanatory.
No, it isn't.
So you need the definition on the other side to know what you're going to receive.
Yes, you need the contract to deserialize whatever you have.
Because if
otherwise you don't know what you're
change this contract, and you would even just swap out name and email, it won't map.
It'll break.
Yes. Okay. But
Or at least you will have name and
but
email.
having
email
that
name.
contract there or having that expectation there, you can leave out a lot in the actual transport.
Yeah, so 157 for XML, 142 for JSON, the same file in protocol buffer, 40 bytes. That's
a lot.
That's a huge difference. Now, extrapolate that to the larger classes and stuff that we have going over the lines right now. This is a lot smaller than normal.
Yeah, if I can shave off half, it would be nice, but this is a lot more even.
Yeah, it's almost a factor 25. It's almost 25% of the XML. So that's actually pretty cool. Now, the usage scenarios for gRPC is if you want to have efficient connection between polyglot services in a microservices style architecture.
Yeah.
I'm not really sure if this is going to be in addition to REST services, or if in the end this is going to replace REST services. I don't think they will. Because I think the power of, for instance, REST services is the fact that even though you don't know the contract, you can just call them, see what comes back, and use it.
For APIs, it's great.
Yeah.
Like you just can go in there, everyone understands it. The HTTP protocols, we all know it.
Yep.
But there are stuff that we replaced in the past that we all knew.
Yeah.
So maybe this is...
Well, it could be, but I think it will be a nice addition to the ecosystem that we have in developing software with services, but not a replacement for REST.
No, but I can imagine if you're doing microservices, you have services talking to each other, which you are in control of yourself.
Yeah,
you have a really efficient transport.
Then it's awesome to be able to have this low latency, high performance solution. If you know who's talking to who and what the contracts are, then this will be awesome.
So what I now heard is also because in .NET Forward going from 3 to 5 and therefore you see that WCF dropped and it had some protocols there that had high performance. Like not everything was just HTTP connected. You could use another transport there. So you see that in bigger environments that's used. So is this one of the options to go with?
Yes, it is. And then next to that one, it also supports HTTP2, which means that the streaming is a lot simpler. And there's a lot of performance improvements over there. So again, I think this is going to be an excellent addition, but it will be an addition as far as I'm concerned. But I'm not sure if I'm correct.
Use it when fit.
But that's the same for everything in software development, right? Because people say, okay, I need to do microservices because everybody does microservices.
No, you need to use the right tool for the job.
That's it.
Change it if it doesn't fit. And don't do it just because it's hip. Please try it out because it's new, because then you have it in your toolbox.
Yeah.
And
that's it. It's an addition to your toolbox.
Yeah, it's not an addition to your current stack. It might be, but it is not.
Don't swap out your hammer for a screwdriver because it won't work. Add it. So core feature, you have an idiomatic client library in 10 languages currently. As I said, it has bidirectional streaming support with HTTP2. And it's highly efficient on the wire because of the protocol buffers and the small overhead that we have right there. So in the end, as you can see here, we could have a C++ service, which is a gRPC server, which also accommodates a Ruby client or an Android Java client, all talking towards each other because in the end they talk protocol buffer and they do gRPC, and it doesn't matter which language it's written in.
And that's a nice thing because gRPC it's a standard. It's not part of the Microsoft stack or whatever. No. It's a standard that's there, so you also see all kinds of other environments that can use this, will use this.
Yes, and it's even that gRPC started a long time ago as a Google project. It's currently open source, and I think Google is still a big supporter, but I'm not really sure if it's Google owned. I don't think so.
I think it's on its own. It's really an open project.
I think so too, but the cool thing is that it has been used for quite some time now, and apparently all the big services that you use from Google, like Gmail, they all use gRPC. So it's not a new kid on the block.
It's hardened.
It is hardened, yes.
Okay.
So current supported languages incorporate C++, Python, Ruby, Go, C#, but also Objective-C for iOS or Java, including Android support. So that's actually pretty cool.
Yeah.
there is a web client. That's just a little bit harder to do.
Yeah.
So let's dive into a demo. And first thing to show here is that this program uses Create Host Builder to actually self-host a service.
Yeah.
And then we create the host builder here, and we use a web builder to use the startup thing. So in startup, as you showed in the previous talk on ASP.NET, here we can see services.add gRPC, which means that we have gRPC available. And for the endpoints, we map a gRPC service, which is called the greeter service, and we map it to the endpoint. So now we have an endpoint to talk to our greeter service. And now the cool thing is, if we go into our greeter service, is actually just a C# class. That's the service that implements what we're trying to do. But on our greet.proto, here's where the magic happens. So this one at first says, let's use version 3 of protobuffer.
Okay.
And version 3 is what's needed for gRPC. Then it says something about a C# namespace, and it packages the entire stuff as a greet. And these are the classes that we used to see in protocol buffers. So for instance, in previous versions, we used .NET library to add attributes to a C# class to define a contract for for protobuffer.
Yeah.
Well, now we can just define the entire message, for instance here, a hello request and a hello reply, inside of a .proto file.
Okay.
So we have two messages here. This is the request message, so let's say the body of your post. And this is the reply that comes back from the server. And then here we define, okay, so we have this service, it's called greeter, and it does a remote procedure call to say hello. It passes in the request and it returns the reply.
Okay, so it's almost like writing your documentation of your communication first.
Yes, because this defines what the service is and what it does, and what goes in and what comes out. And then to consume this, for instance, we could have the same proto file, which I actually linked from this definition.
Would be nice if they're the same definition.
Yes, that would be nice. So here we have this package that's in a gRPC.NET client. It's a gRPC channel that we create for our localhost address at this point. And then I have a do while here that actually says, give me your name, and then it calls the service and it shows the reply, and then give me your name, and then as long as we keep typing names, it will keep working. One thing that is important, go to the properties of the file. Here you can see that in the client, I specify that for the proto file, I only want to see the client classes. While, move this one out of the way. While if we go to that same file under the server project, there I specify I want this to be a server thingy.
Okay, but it is one file at the moment.
Currently it is one file and it's linked from one to the other. Now, first off, let's start the service. And then the downside is I can't call this service from, for instance, Postman or a browser. And that's
because calling it, you would need also the proto file.
Yeah, and like you can see here, we map the get on the slash to say communication with a gRPC endpoint must be made through a gRPC client. It's not a REST endpoint.
You just map
gRPC.
the route to say something if you don't know what it is. Okay.
So we have it up and running now. It's right here. And then if we go into debug the client that we have, we can see that there will be some communication going on. So here's the bottom right is the server, the top left is the client. And then when I say I'm Oscar, the first time it takes some time and it says the greeting is hello Oscar. So the first time it takes 150 milliseconds.
Okay.
Is
it checking?
It has nothing to do with you. It's the first
not my
time.
name. Okay.
It's the first time. It's initializing the client and it's initializing the class on the server
But is
side.
it evaluating the proto file real time?
No.
That's not or is it compiled in?
It should be compiled in.
Okay.
That's actually a nice question.
Oh, we can dig out
Yeah.
later.
So you can see
this was fast.
8 milliseconds. So if we do Betatalks, again 12 milliseconds. So this is really fast, and you can keep hitting it. It'll
Yeah, but the
keep-
connection is open, so you can just talk.
It's fast, right? So if I do Q, then I set it, the client should exit.
Mm-hmm.
But here you can see how freakishly fast almost you can use a proto file or a gRPC implementation where I have a client which is self-hosted, a server which is self-hosted, and then a client that uses the gRPC channel to talk against the server side. And as soon as the connection's open, it's fast.
Yeah, but it's almost zero overhead. It's just pushing data in and out.
Yeah.
So if you look at a HTTP GET or whatever, the amount of headers that's pushed on there, it's amazing.
And you have the acknowledgements and all this stuff going over and the handshaking.
And you can actually here just push out to the client.
Yeah.
Really cool.
So it's really...
really interested for some scenarios, at least.
Yeah, well, you know, I heard about the fact that it was coming in, and then I wanted to see how it actually worked. And then I thought, well, this is probably going to be hard. But it's like almost no work at all, and it's there. I mean, sure, you need to know how the .proto file works, and you need to know to set it to be a client or a server. And I actually tried to implement it first with an Angular front end, but then you need the web solution for generating the client to talk to the gRPC channel. That's more work than just 5 minutes.
Yeah.
But still, it's not a lot of work. And then you have the client, you can just talk to it. But as you can see here, using just C# with a self-hosted server and a client talking to each other on the same machine, it's a matter of minutes, you get it working.
Yeah. It's really nice to see a simple example to understand what's going on there before you start building an app and depending on a new technology like that.
Yeah, but also I think, as with a lot of new technology that comes in, at first you think, oh wow, I need to look into that once, but it's probably going to be really hard, and I need to get my first hands on it, but it's probably going to be hard. But as soon as you actually dive in, you see it's not hard at all.
You can do this in half an hour, an hour. Like everyone has that at some moment.
Yeah.
It's really good.
Yeah, cool. So one final warning, if you want to jump into this and actually want to use it in production, I have it on screen right now. It's currently not supported on Azure App Service. And that's because Azure App Service, the HTTP2 implementation of HTTP sys is not compliant yet.
No.
And the reason is that gRPC has headers that they send after the response. So headers aren't always the first thing to go over the line.
Yeah, and that's kind of a rule normally.
It might be the reason they're
call it headers, yes.
There is an active GitHub issue open, so if you go to the documentation on docs.microsoft.com about gRPC, you will see this warning. The GitHub issue link there is clickable, of course. And there you see that, for instance, David Fowler is talking about they're currently working on the HTTP sys implementation.
Okay.
Trying to get it up and running.
So if you want to host this now, you go to containers or something like that. Because you're hosting it yourself.
Yeah.
Really good.
So that's if you want to go in production, but to play with, you can even do that locally, so that's fine.
Okay. Well, thank you for this demo. Really cool.
You're welcome. Thank you for watching.
See you next time.
See you next time.
Bye-bye.
Bye.